All right, welcome everyone. We're going to talk about Module 1, which is Introduction to Cloud. And in this particular section, we're going to talk about three areas in today's video. So we'll start off with Introduction to Cloud. We'll talk about cloud enablement technologies, and then we'll shift gears into cloud business impacts. And so I do have a whiteboard up to kind of walk through things on the whiteboard as they apply for some of the material. So without any further delay here, let's just go ahead and get started on that. So, introduction to cloud. So this particular unit is going to give you an introduction treatment to cloud computing. We're going to talk about the different service delivery and deployment models. We'll talk about how cloud and traditional IT models are different. We'll talk about business impacts, financial models, and basic capabilities are common to cloud platforms. And then I will wrap up this particular first portion of the unit on how these cloud technologies have transformed the job market, which I think is very important for all of you. So let's start off with what exactly is the cloud? Well, the NIST, which is the National Institute of Standards and Technology, has a definition. And so in today's reading, you should have found that link to the NIST standard, and you can read up on what cloud is from NIST's perspective. That being said, NIST has a lot of publications that are utilized quite heavily in the cloud-based environments for compliance and security and things like that. So the NIST website is a cornucopia of information that can be helpful to you in your careers. The equivalent of NIST outside of the US is the International Standards Organization, which is ISO. Now, cloud computing, it provides rapid access to shared pools of resources, and resources are things like compute, storage, networks, services, libraries, applications, databases, etc. And it does so in an on-demand utility-based models. So think of the way that you consume these as the same way we consume electricity. Very few people go and run a power plant at their house, but they do use electricity, and they get it based on usage, and that's how they pay for it. Now, characteristics of a cloud computing model include things like self-service. I should be able to just go out, request a service, and obtain the service. I shouldn't have to go to a human being. Broad network access, meaning I should be able to access the service from pretty much anywhere. Resource pools, meaning we have a pool of resources that multiple customers can use, and I don't have to have a pool dedicated to me. Rapid elasticity, meaning as my business needs the resources, I can obtain them, and as they're no longer needed, I can return them to the shared resource pool and no longer pay for them. And then the last thing is metered resource usage. So I need to have a way to meter what I'm doing, just like we have a water meter, a gas meter, or electric meter. Now, there are three service delivery models that are the primary model, Infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. This class is going to be primarily focused on infrastructure as a service, but we will talk a little bit about platform as a service and SaaS. So infrastructure services like compute, storage, network, these are virtualized and they're consumed through the internet. And we use these in a business to deploy applications, our operating systems, databases, etc. We have significant control over what we run on this platform, but we have no control over the underlying hardware. And examples of companies that provide this type of service are Google Cloud Platform, Amazon Web Services, Microsoft Azure, and then there are a few others that are much smaller. A platform as a service is where we take something like a library, a programming language, a database, an API, etc. And we provide this for consumption where you build your application on top of this platform. So you subscribe to a PaaS service, you deploy your application, you have no visibility into, nor do you have the ability to manage any underlying infrastructure. And that includes the hardware, like the storage, compute, or networking. And some example of this would be Heroku, AWS Elastic Beanstalk, and Google App Engine. And then lastly, we have software as a service or SaaS. And this is when we have an application that's provided for consumption through the internet. And so as an end user, we sign up for a SaaS service. Our business can do this as well. And we obtain access to this application. We aren't responsible for anything. We just expect it to work. So an example of SaaS would be Box, Dropbox, Google Drive, Google Apps for Business, Slack, Office 365, Salesforce, and the list goes on. Okay? Now, once we have an application deployed on SaaS, we're good to go and we can start using it. We also have something called a deployment model. And so there are multiple cloud deployment models. And you generally see these for IaaS services, but I suppose you could see them for PaaS or SaaS in some cases. The cloud deployment models that we have, primarily in this class, we're going to talk about public cloud. And in a public cloud environment, this is just designed where anybody in the member of the general public can just go out and subscribe to it. Now, there can be different classifications for different regulatory requirements, such as HIPAA, PCI, geographical restrictions, such as European, Asia Pacific, North America, South America, etc. And there could also be security restrictions where we have high security, low security, etc. Examples of public cloud, the three biggest providers, as I mentioned earlier, are Google Cloud, Amazon Web Services, and Microsoft Azure. Now, a private cloud environment is designed for use by a single organization. And so all of these public cloud providers also provide a mechanism to do a private cloud. And by private cloud, this just means that I can manage my infrastructure the same way that I could if I were using a public environment. I have elastic services, shared resource pools, and the organizations within my organization can actually go out and subscribe. An example of such a tool would be OpenStack. And so OpenStack is used a lot by companies who want to do private clouds. Now, a hybrid cloud is when an organization says, I'm going to use public and I'm going to use private clouds, and I'm going to use some sort of technology to facilitate the interoperability of these platforms, including the data exchange. Okay? And then multi-cloud is when we have an organization who wants to implement multiple public cloud providers. And this is done to minimize the risk of vendor lock-in. So with multi-cloud, we use public providers and we leverage third-party tooling to help us manage resources across those providers. And we'll talk about the tooling in modules 5 and 6 later on in the course. But at a single cloud level, you can actually utilize the vendor's tooling that comes from the cloud. So if you're doing AWS, you use their tooling. If you're using GCP, you use their tooling. It becomes more complex when you have multiple cloud providers. Now, one of the things about public cloud is if you do a multi-cloud version of public cloud, you're minimizing your risk of vendor lock-in. And what does that mean? Well, that means if the vendor decides to increase the cost, if you're multi-cloud, you just shift more resources to a different vendor. If you're just using one cloud provider, if Amazon raises their rates, you're stuck paying those rates. Okay? And then the last type of deployment model is community cloud. This is not very common. This is for something like a general community of similar users with similar requirements. So let's just say that the intelligence community has an intelligence cloud. Maybe there's a some other type of community, graphic artists or something, created a community cloud for them to all share, that sort of thing. Now, let's talk a little bit about the differences between cloud and traditional IT service delivery models. So the primary difference here is who's responsible for what. So I'm going to start with cloud. With cloud, you have the least amount of responsibility. And it goes down in terms of responsibility, starting at IaaS. IaaS, you have the most responsibility. You're responsible for your virtual machines, your operating system, your applications, your database, all the services, libraries, etc. But you're not responsible for the physical hardware, the physical network, the data center, the cooling, the power, getting telecom and things like that. With PaaS, you're responsible for your application, but nothing else. With SaaS, you're responsible for nothing. Now let's contrast that to a traditional IT delivery model where you are responsible for everything, ranging from your application and your website all the way down to the hardware and even further down to the physical building it sits in and the land that it sits on. So if you are running your own data center and it's located up in the Bay Area where there are fires right now, you've got to think about that sort of thing. Whereas with the cloud provider, you don't need to think about that sort of thing. Okay? What is the impact of cloud on businesses? So there's a really great article here you should take a look at. It's listed in the reading assignment. And it talks about the impact of cloud computing on enterprise software. Okay? Now, there are different cloud financial models that providers use to make money because it's all about making money at the end of the day. And so we have subscription-based, where we have, say, a monthly subscription for some sort of service. We have usage or utility-based. We could have a freemium model where we pay for a certain service and we get the basic service for free. We can have free, or what is also known as advertisement or data supported, because there is no such thing as a free lunch, or some combination thereof of the above. Okay? So if you're using a subscription model, this is similar to just renting a home versus buying one. When you rent a home, likewise, when you subscribe to a service, you get a specific set of services for a fixed fee. Okay? So using the home analogy, if you're renting an apartment, you get usage of that apartment. Maybe it comes with a garage. Maybe it comes with a washer and dryer. Maybe the utilities are included. Maybe they're not. Okay? But your lease specifies what you get with that particular subscription. Same thing with cloud. When you sign up for a subscription, you get a certain set of features or services. Okay? And so companies like Salesforce and Google Apps for Business use this model. Now, you can also have services that are based on a utility or usage-based model, which is very similar to how we purchase electricity, gas, water, sewer, etc. Okay? And in this case, your usage is measured and it's billed based on your actual usage. Okay? And so examples of services that use this are AWS, Google Cloud, and Microsoft Azure. Now, we also have services that use the freemium model. So this is where you get a taste of the service for free, and then if you want add-ons, you pay for more. You pay money for it. Okay. So Dropbox, Google Apps, Box. These are freemium model services. And then you can sometimes have cloud services that use a free advertising model or data-driven model where your data is the product that's monetized. And so an example of this might be Google Docs. Okay. Not the Google Docs that you use through school, but the Google Docs you use on your personal account. So what are the basic capabilities of cloud? I touched on this earlier. All cloud-based systems have the following basic capabilities. They must be on-demand self-service. They must have broad network access. They must have resource pooling and rapid elasticity. Those two go hand in hand. And then they also must have some sort of measured service. Okay? Whether that's under a subscription model, you have certain criteria that you're allowed to do. If it's a utility model, your actual usage is being metered. Excuse me. Okay? If you have a cloud provider who does not have these areas, they are truly not a real cloud provider, even if they call themselves a cloud provider. And there are companies out there like this. Now, I promised you to talk a little bit about jobs. So in addition to our Teams room, where I've got a channel just dedicated to careers and development opportunities like conferences and stuff that are free for you, I wanted to talk a little bit about the job market transformation. So cloud has really changed up the job market in the last 15 years or so. So there's some very in-demand jobs, and this class will set you up for success in those particular jobs. You will still need to do your own work on further developing your skills, but you'll have a good foundation to start with. So in-demand jobs that are very valuable right now. DevOps engineers, okay? And I've linked to a blog post on what exactly does that mean. Site reliability engineers, or SREs. This is something Google invented. There's a free book about SREs from Google, okay? And I've linked to that. Cloud architects. And so I've linked to a CIO magazine article that you should read. Okay? Cloud engineers, I've linked to Amazon, which talks about their AWS service, and cloud engineers over there. And then a product manager. So I've linked to a Forbes article about product management. And then lastly here, DevSecOps. So this is taking DevOps and adding security into the mix. Okay? And so again, I've linked to resources with more information. With respect to certifications, there are certain types of certifications you can get while you have very little experience or no experience. And then there are certifications you can't get until you have experience. I don't even link to any certifications that require experience simply because they're irrelevant to most of you. Okay? But certifications you can get with little to no experience are things like the certs for Microsoft Azure. Okay? So you can go out there, take a look at the exams that are out there, and decide whether you might want to take one of those and get a certification. GCP and AWS as well. And then lastly, CSSP if you're more interested in the security side. And then I've also linked to a CIO Magazine article about security certifications and cloud certifications. But in terms of skills, the skills that you're going to exercise in this course that are very desirable, I've called out. So you're going to learn GCP. You're going to learn Amazon Web Services. You're not required to learn Microsoft Azure, and I won't teach it in the class, but Microsoft Azure is a free service that you can sign up for through the GitHub Student Pack that you'll find in Module 5. So you can sign up for that, and you can explore that on your own as well. I highly recommend that you learn all three, even if you specialize in one of the three. But you should have the ability to work your way around all three eventually. Containers are another area that we're going to talk about in this course that are very desirable. So any of the different container platforms, which we will get to in a few weeks. GitHub for source code control and management, and then Terraform for automation of your cloud-based provisioning for multi-cloud. And that's it for introduction. So now let's move on to some of the enablement technologies. So in this particular unit, we're going to help you to identify enablement technologies for cloud, like what did we need to do first in order to be able to facilitate having cloud-based platforms. We'll talk about different types of virtualization, and you should be able to understand the differences. You should understand and be able to demonstrate using containers. So you'll practice that in your assignments. And then you should have a basic understanding of what an API is used for. So let's start off with an introduction. So in the past 15 to 20 years, we shifted from organizations buying hardware, software, expensive services, and having multi-year projects to a world where we can push a button and turn a new IT service on in a matter of minutes. So how do we get there? There's been a lot of development over the years. In particular, automation and software-defined services have really enabled us to grow. We've also shifted from hardware focus to software focus, otherwise known as infrastructure as code. Okay? So if you are planning on going into a career in the hardware world, I hate to burst your bubble, that's not where the careers are at. Being a physical network engineer, yes, there are still some jobs for that, but largely it's shifted to software. So don't get too hung up on that. Likewise, storage engineer, there was a time when that was a huge growth career. These days, storage is more software than hardware. So that's not really a great career path for you as well. Now, being software doesn't mean you have to program, but you do need to have an understanding of how to do things in software. Okay? And we'll do that in this class using a variety of mechanisms. Now, at the same time, we've seen networks get faster and faster. We've seen hardware costs drop to next to nothing. And we've seen virtualization enable us to improve utilization of our existing hardware. Meanwhile, applications become complex and broken down into what are called microservices. And we've also seen an evolution of storage. So we've seen a huge rapid growth, and this in combination with the growth of cloud has led to a shift in IT workloads over to cloud-based platforms year after year. Okay? So let's start with compute. And so compute in general, we use cloud-based platforms, And we use virtualization to carve up pools of physical hardware resources into smaller logical resource pools. Okay? So virtualization software manages those logical resources, enabling us to more efficiently use our hardware. So as an example, any of us can install virtualization software on our laptop and then install a second or maybe a third OS. Okay? So if I'm running a Mac, I can install Windows and Linux in virtual machines on my computer. I can even install Mac in a virtual machine on my computer. Let's say I want to test a new version of the Mac OS or something. Okay? Windows users, you can install Windows or Linux on your machine in a virtual machine. And so we can use our hardware more efficiently and use it for testing and learning purposes. Now, with respect to virtualization, this is a technique that enables us to run multiple operating systems and applications on a single hardware device. This technology is not new, it's been around for a long time, but it's been modernized. It's much more effective these days, and we can use it on a very large, diverse set of resources. Now, today there are three types of virtualization, two of which we're going to commonly find on cloud platforms. That would be full virtualization and containerization. The third is only going to be found on desktops and laptops these days. That's called paravirtualization. And I'm going to talk a little bit about each one of these. So with full virtualization, otherwise known as a type 1 hypervisor, there's a piece of software that runs directly on the hardware instead of an operating system. So with full virtualization, the computer doesn't run Windows, it doesn't run Mac, it doesn't run Linux. It runs a specialized operating system, I guess you could call it, which is called a hypervisor. And then your virtual machines can run on any compatible operating system on top of that hypervisor. So three examples of full virtualization hypervisors are Linux KVM, which is free, VMware vSphere, which costs money, and Microsoft Hyper-V, which costs money. These are all examples of full virtualization. Now, on our local machine, we can run paravirtualization or a type 2 hypervisor. And in this case, we still run our operating system, be it Mac, Windows, Linux, but we run the hypervisor as an application on top of that operating system. So the operating system is still responsible for managing the physical hardware and giving resources to the hypervisor. Okay? So the hypervisor is kind of like running Microsoft Word on your computer. It's just an application. And then that application runs an OS virtualized with its own applications. Now, examples are VMware Workstation on Windows, VMware Fusion on Mac, VirtualBox, and Parallels. Some of those are free, some of them cost money, some have academic versions which are significantly discounted. Okay. I've included a link to VMware because, from my perspective, my opinion, of course, of those virtual machine options, they are the best option, most features, and less likely to crash on you. Okay? But for a full virtualization comparison, you can read a technical paper that's out here. Okay? Now, what are some of the advantages of virtual machines? We can run multiple operating systems on the same physical hardware. So this means I don't have to go out and buy a second laptop if I need to use Linux in one of my classes. Okay? If I'm running a Mac and I need to do Windows on it for a particular application, I can just run it on my Mac as a virtual machine. So there's that benefit. It's also very easy to maintain. So I can patch virtual machines without rebooting my regular computer. I can snapshot, which is literally like taking a picture, okay, of a virtual machine as it is, upgrade it, and then if I have problems, I can revert back to that snapshot that I took and continue working. So it allows me to have better maintenance. I can more efficiently use physical hardware. So if I've got a very expensive server and I run virtualization on it, I can run more things than if I just ran one operating system on that. And then this also lets us reduce our total cost of ownership, because if I want to add capacity, I buy perhaps a bigger physical piece of machine, And then I can use it for multiple departments' applications, okay, as opposed to each uh, department having to build or buy their own machines. Now, some disadvantages of virtual machines: there could be resource contention if you're running multiple virtual machines. The hypervisor or the host OS can consume a large amount of resources. Hypervisors are not necessarily as efficient as a host OS. The virtual machines are not lightweight. The recovery can be slow. We can have complex administration of the system, and we can have lengthy boot up times. Okay. Now, let's shift gears to containerization. I waited to the end to talk about containerization. So with containerization, the operating system is abstracted rather than the hardware. So the operating system manages all the hardware resources, and there are no other operating systems installed. Okay? But what containerization allows you to do is have these little semi-isolated environments to run a specific workload or application. That's called a container. And all that is a logical partition of the operating system. Okay? So they contain things like your application files, configuration files, maybe libraries, etc. But they don't contain any of the operating system files. So they don't contain any Windows, any Linux, any Mac. Okay? Now, an advantage of this is these can be created and launched in a fraction of a second instead of minutes for virtual machines. Containers are very lightweight. They're faster than virtual machines, and they offer fast processing and execution. And so the one that's most commonly used is Docker. Okay? And Docker is something you can actually install on your computer. I have it installed on the computer in my office here. Okay? Docker allows me to stand up a container very quickly. Now, we will be using Docker in this course, but we'll be using it out from the perspective of I'm going to create a Docker set of containers for the project, and for potentially some of the homework assignments, I'm going to make those available on a public Docker hub, so you'll be able to just download them to be ready to go. You won't have to configure them. And then you'll be able to deploy those to your cloud environments out in Google and Amazon. But there are other alternatives as well. LXC is one, Apache Mesos, and Vagrant. Those are all container technologies. Okay. Container orchestration systems exist like Nomad, Kubernetes, Amazon ECS, Microsoft AKS, and Google GKE. Okay. These are used to manage containers. And you can find examples of those in the material that I have you reading. So containers have advantages of being lightweight, efficient, and they're fast to start up. But the disadvantage is they only support a single OS. The management can be complicated. Okay? And a great example of that is Kubernetes. Kubernetes is extremely complex. Okay? We are not going to use it in this class. It is far too complex. That being said, if you want to learn on your own, Kubernetes would be good for you to learn because there are a lot of jobs supporting it because it is so complex. Okay? Another disadvantage of containers can be security. Can be a bit challenging to implement properly. Okay? And so in the materials, I have additional supplemental resources you should take a look at. Now, the last section we're going to talk about today is cloud business impacts. So let's talk about the impact of cloud technologies on businesses. Then we're going to talk about how cloud technologies led to the democratization of technology for businesses. And then we'll finally close out with how these technologies have changed business balance sheets. Okay? So in general, cloud-based technologies lead to lower cost IT services. They expand availability to be more broad, and they give you greater choice. Okay? So when you search for payroll providers, you'll find a lot of different options. And you'll find the options that have historically been around, like ADP and Paychex, but you'll also find smaller SaaS companies like Gusto and Zenefits. As a business, you have many choices today that you didn't have previously. So you can choose whatever best meets your needs. This wasn't always the case, though. You used to have to be a mega company spending millions of dollars to get this type of solution. When I was in college, I had to run payroll for the business I worked at, and I had to manually do it by adding up time cards. okay, and then issuing paper checks. We don't do that anymore. So we've really lessened the burden for business owners. Now, in the past, it wasn't financially feasible for SaaS companies to actually proliferate because prior to IaaS being available, it was not cost effective to run your own SaaS company. And by the way, before it was known as SaaS, we had application providers that were known as ASPs or application service providers. That's like the grandparent to SaaS. Okay, and back in those days, we didn't have IaaS, so each one of those had to stand up their own, and it was expensive to stand up that technology. So IaaS has really enabled PaaS and SaaS to take a foothold because these companies can get very low cost software and they can run their applications on top of these providers. So today you can set up payroll in a matter of minutes, and I've done it myself. So when I had my business, I could set up payroll. It literally took me 5 minutes to set up payroll for my whole organization. And the cost is not significant. Now, there are a lot of other niche SaaS providers that offer services in a variety of areas. And so if you think about transformation of businesses, I worked for a company that was a large IT services firm, billions of dollars in revenue. And at the time I worked there, they were still using 1970s era mainframe computers to do expense reporting and still require that you mail your receipts to their headquarters to be manually processed. It took a long time to get reimbursed. Okay? You'd have to float expenses for a very long time because there wasn't a better way to do it. Now, there's a better way to do this sort of thing. Okay? And this wouldn't be possible without SaaS, and that wouldn't be possible without cost-effective IaaS solutions. Now, the democratization of technology refers to the ability of small businesses to have IT capabilities that are on par with what the larger companies have had for a very long time. So companies can have, these days, IT capabilities that are on par with what these larger organizations typically have. Okay? And so that's really enabled these organizations to better compete in the marketplace. And then the last area we're going to talk about is the impact of business balance sheets. So cloud computing's had an impact there as well. On-premise computing is very expensive and it requires a lot of capital and operating expenses, which have to be carefully forecast, say a year in advance or more. And then what if things fluctuate? Then you've got to go back and recalculate and adjust your spending accordingly. This is all a manual process. With cloud computing, these expenses are all now out of the operating budget. So now we don't have to worry about capital expenditures. And now we can align those expenses to be more variable based on our variable revenue. Okay? So we can expand during busy periods and contract during slow periods and not be subject to a minimum spend. And a great example is during COVID-19, companies like Zoom had to rapidly expand their infrastructure to support the big growth and usage that they have. Okay? That's it for Module 1. Make sure you read and watch all the videos for Module 1 and do start your homework so that you can actually get through those exercises and get some practice.